Hello, Mario. In this video, we're going to take a look at coordinates. Most of you should be fairly well familiar with coordinates from basic maths that you have perhaps learnt at school. And here we have the typical XY coordinate plane, horizontal coordinates, two-dimensional coordinates. We're usually familiar with the positive x-axis starting at 0 here and heading in a positive x direction this way, and starting at 0 here and a positive y direction in up page. We then have a negative x out to the left and negative y down to the bottom of the page. The axes being represented by number lines, numbers increasing, positive this way, negative that way. Now any point on the plane can be defined in terms of the axes and an x ordinate and a y ordinate. So here we have a point here which we can call x, as it's this way along x distance along the x-axis, and y distance along the y-axis. So we give that the coordinate x, y. If we move over into the second quadrant, we can see that we have negative x, y. And similarly, if we move down into the third quadrant here, we have negative x, negative y, and over into the fourth quadrant here, x and negative y. And we have our central point, or the intersection of our x and y axes, and at the point 0, 0. Now we can see here that in dealing with these numbers there are a number of problems that we can identify. One is the use of negative x and negative y. The use of negatives in any form of arithmetic and that can cause problems, leaving off the signs and dealing with the actual mathematics itself of subtracting a negative, adding two negatives. These are all complications that if we can avoid them, we should. So as you can see, or as I've shown here, you can define any point on this horizontal plane in terms of x and y coordinates. Now in surveying, we tend to work in directions or bearings, bearings being angles that are measured clockwise from north. And we tend to use north and east predominantly. But if we look at our two-dimensional xy axes and put in north, south, east and west as we know them to be, you will see that the y-axis, or the y-coordinate, is a distance north of the origin, and the x-axis is a distance east of the origin. So we can see quite clearly the relationship between x and east and y and north. Now this is only in the two-dimensional plane. So let's go and have a look at the three-dimensional plane. Now we still have our horizontal plane, which we can define in terms of x and y, or east and north, but we can add a third dimension, z, the z coordinate, which correlates in surveying to height. Height above as a datum of 0, or value of 0. So we can have positive z, which is heights above 0, and negative z, heights below 0. And this enables us to determine any point in a three-dimensional plane with a series of ordinates, as I've shown here in the diagram, x, y and z. Now in surveying, we normally show our ordinates, or we like to, or it's traditional in New Zealand anyway, to show our ordinates in terms of northing, easting and height. But as you will see from the diagrams, that correlates to a YXH format, or YXZ if you want to call H the Z value. Whereas the mathematicians and some of the software, notably AutoCAD, prefer to use an XYH or height or XYZ format. So when we are dealing with coordinates, it's important, very important, that we know which format our coordinates are in, and that we can distinguish between the X coordinate and the Y coordinate, and the Z coordinate for that matter. But generally, distinguishing between the X and Y is very important, and what format our coordinates have been given to us as. So there's some important things there that we need to know. Now let's just move ahead and look at the actual local situation. Now the first thing, or the first problem that we encountered, as I explained, was the idea of having negative X, negative Y and negative Z for that matter. Now one of the ways that we get around that problem is that we take our coordinate axes, X, Y and Z, as I've shown on the previous slide, and we give the origin what we call a false origin. Now initially this was for the 1949 datum. The false origin of Mount Eden, which is the centre of the local origin in our area, was given the false origin value of 700,000 north and 300,000 east. So this would put the origin 0,000 over here, over here to the west of the and south of the origin. So what this means by having this large value for the false origin is that everything is in the first quadrant, where X is positive and Y is positive. And we can see here that in the case of the example that I've cited here, just with the two-dimensional XY plane, with 700,000 and 300, you can see that any values up in here would be 703,000, 304,000, and they would all be in add plus plus. But over in this quadrant here, you can see 296,000, which is less than the 300. But hey, it's not negative; it's still positive. So it's still, we can still deal with it. And down in here, we've got where with the traditional XY or 000 origin, we would have them both negative. Here we've got them less than 700,000, less than 300,000, but nonetheless both positive. And over here both positive. So one of the ways to make the mathematics easier is to use the concept of the false origin, so that all our coordinates are in the first quadrant, or are, in terms of surveying, northings and eastings. Now you will from time to time have to develop a coordinate system, and you will be using a false origin. And I must stress how important it is that you have the separation between the northings and the eastings. If you look at these coordinates here, you can see that there's no real doubt as to which one's the northing and which one's the easting because of that separation. If you say have them both the same value, 700, if they were both 700,000, it would be very difficult to determine just by looking at them which was the northing and which was the easting. And I have seen this is quite a thing that's done where they have similar values, but I would really implore you and suggest to you the best advice I can give you is to have your northing and easting as far apart as you can, yet still cover the area. Still, you know, so that you've always got positive coordinates and no negative coordinates. Because even with a false origin, if you go far enough, you will still you can still get negative values within the area, but generally not. I mean, 700,000 there is 700 kilometres, sort of, you know, and 300 kilometres. So you're not getting in the way that we do things. We don't have these what we call meridional circuits going over such large areas. Now, in the case of heights, the z coordinate, it's usual that the origin or the zero of the heights is sea level. Mean sea level. Now, sea level fluctuates cyclically through a 19-year period. So at some sites around New Zealand, the sea level has been measured continuously and the mean sea level has been determined. That has been given the value of 0 height, and then heights above that level positive and below that negative. Although on the land and for most of our surveying situations we do not go below sea level, and hence we don't have the negative values, so we tend to use sea level or mean sea level at 0. However, there are some situations where we do go below sea level, and to avoid those negatives we can use an assumed height datum, and so we might have an assumed datum of 100 metres. Now, a couple of examples I can think of are some of the coal mines in Huntly, where the actual ground levels are sort of around 20 metres above sea level, above mean sea level, and they're going down 60-80 metres, so the actual bottom of the mine and some of the workings of the underground mines in that area are below sea level, and so an assumed height datum is used there so that we don't have to deal with negative heights and the problems associated with the mathematics of using negatives. Locally, just looking at the local situation, firstly the local coordinate datum is the Mount Eden datum, and this datum dates back quite a number of years. Initially it was called what we call the old cadastral datum, where they didn't allow for the curvature of the earth, and then in 1949 they created the Mount Eden geodetic datum 1949, where the curvature of the earth was taken into account. And in the 1949 datum, the false origin of 700,000 metres north and 300,000 metres east was adopted for geodetic 1949. Now, since 1949, I've done a few studies. Gear has got more accurate, and in 2000 they decided to use a new datum, a dynamic datum that allows for some movement of the Earth's surface over time, and the new datum, New Zealand Geodetic Datum 2000, adopted a false origin value of 800,000 and 400,000. So you can see in both instances the 700,000, the 300,000 probably the optimum, but the 800,000, 400,000 still does the job nonetheless. 6-figure values that give good false origins, easily identified coordinates. We know which is the northing, which is the easting, so they're very suitable. Now, for your own work, you may find that 700,000 and 300,000 is giving you more numbers than you really need, so it can be simplified so that you can use perhaps a 7,000 and 3,000 if you were assuming a an origin on a job that you're working with, or even 700 and 300 on smaller jobs that perhaps don't extend that far. So when you're in a situation where you are using, or you need an assumed coordinate datum, I would recommend to you that you have a good separation. Make sure you can cover the whole area. In terms of your heights, you might want to have a good look at that. Make sure that you are going to be above sea level for most of for all of your values. If you're close to sea level, and there are some areas close to sea level, as I explained, Hamilton itself is approximately maybe 30 metres above sea level in some parts. So if you're digging a hole in Hamilton or boring down and going more than 30 metres deep, you might want to consider using a false origin on your heights. Remember that the local datum here is Maurieo datum. Maurieo datum originates from out of Mount Maunganui, just a little island out of there where the tide gauge was, and it's been transferred over here to the Waikato, over the Kaimais, with a spirit levelling, and goes up to the base of the Bombays, out to Raglan. It covers quite a large area, the Maurieo datum, where that's the datum based on mean sea level at Maurieo as observed in a tide gauge. Now, quite often when you're on a job, remember that it's the datum is Maurieo. You may have a benchmark with a value on it. That's the origin of levels for your job. So the origin, you should state the datum, Maurieo, origin of levels, benchmark 45, or whatever it is, and state what it is. So very important that you understand what datum you're using, what form your coordinates are in, northing, easting and height, and sometimes you may want to assume a datum so that you have some good arithmetic and good mathematics acting on your behalf and in your favour.